get QP. QP or PQ. Okay, let's use PQ because we need to prove something. PQ. So for that case, you have now to open the brackets by multiplying in the negative now inside. So here it becomes Q plus Q squared, then minus. When a negative and negative, you multiply them, it becomes a positive. So it becomes plus P cubed, then this one also plus 3PQ. So that's what we get out of that. I think there's nothing which you can make out of this. Is all of them have different categories. So now we are continuing with the question. So we are continuing, now they say that after expressing in terms of P and Q, because we are saying that everything is in terms of P and Q, what we do now, they say that also deduce. Now this word here, deduce, this one means that from where you have stopped, that's where you start from. The words like hence, deduce. So this one, they mean that from where you have stopped, that's where you start from. So they are saying that deduce for one root to be a square of the other, that this equation equals 0. So for that case, from where you have stopped at this point, so now they want you to deduce. So we know that for one root to be a square of the other, like for example, they have given us this one and this one. Like now, if we consider that alpha is the first root, to be the square of the other, because here they have given us the equation in the form of alpha and beta, so that means we are considering now here also alpha and beta. That means for alpha to be a square of beta, this one must also happen that alpha is the same as, to be the square, it is beta squared. So this one is a square of this. So for that case, what we do, we bring this beta the other side, so it becomes alpha minus beta squared, which will give us a 0. Also, they said for one root to be the square of the other. So for instance, also when beta is a square of alpha, what happens? Also that means we may have here that beta can also be the square of alpha. So for that case, we bring this one this side, that beta minus alpha squared, which will give us a 0. So since everything is equal to 0, we can then multiply the two and we equate it to 0. So for that case, it will be alpha minus beta squared, then times beta minus alpha squared must give us to 0. So we multiply the two, we equate it to 0 since everything is equal to 0. But we also know that from our expansion, which they gave us that alpha minus beta squared, then also times beta minus alpha squared is giving us this value here. So this is just an expansion of alpha minus beta squared, then times beta minus alpha squared. So since this one is the same as this one, so we can just substitute in the values or what we got, we substitute just here, then we get the answer to be equal to 0. So that means here it will be q plus q squared plus 3 plus q squared plus p cubed, then plus 3p q equals 0. So now after making it equals to 0, because they said we have to prove that this one equals a 0. That one equals 0. So for that case, if it is equal to 0, so we must know that we must show that it is correct. So what do? We start by this one, which is p cubed So now this one becomes, this one here was a plus here. So it was a plus here like this. So for this case, when you multiply the negative, this one will become now a negative, not a positive. So this one becomes a positive like that. It becomes a negative when you multiply the negative. So this one was like that. So for this case, when we are proving this one here is negative. Now we want to prove something like this. So we begin by this, like what they started with, then we come out with this, that is minus 3pq. Then also indicate this one which is here, plus q squared, then plus the other q. So we give us a 0. Then by proving this one, you would have got what they need. So you must be very careful when handling this one, this thing of multiplying. So you must be careful. So that is what we can get out of that. I think we shall do one more on the other example. We can stop here and have some commercial break.